So all this boils down to the three primary trigonometric ratios, which are made up of the side length ratios within one triangle. The value of the trigonometric ratios depend on the angle to which the opposite side, adjacent side, and hypotenuse correspond. The angle is called the reference angle. So that's the angle of interest that we're going to have in each of the triangles. The trigonometric ratios can be found in a book, which is kind of old school, or a calculator, and a second triangle is no longer needed because the way we did it with these two similar triangles, we don't need those anymore because somebody a long time ago, or many people a long time ago, did all the research for us and worked out all the trig ratios, which is now very handy for us to use. For triangles, in this earlier investigation, we now define three of the trigonometric ratios as sine of angle C, the cosine of angle C, and the tangent of angle C. And the sine of angle C is the length of the opposite side, opposite of angle C, over the length of the hypotenuse. The cosine of angle C is the length of the adjacent side to angle C over the hypotenuse, the length of the hypotenuse, and the tangent of angle C is the length of the opposite divided by the length of the adjacent. Okay? Please keep in mind this is not sin, cos, and tan. These are the sine, cosine, and tangent of angle C. And just to remind yourselves of these, if we take the first letter of each of these, sine, opposite, and hypotenuse, cosine, adjacent, and hypotenuse, and the tangent, opposite, and adjacent, we could have a little mnemonic, so katoa, which would remind you that the sine is the opposite over hypotenuse, the cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. Alright, let's see how this all comes into play. Write the three primary trigonometric ratios in terms of angle A. Well, angle A is right here. So we have to identify the opposite, the adjacent, and the hypotenuse sides in relation to angle A, our reference angle. So the hypotenuse is always the easiest to determine because that's always across from the right angle. So that's this one here, side AC. The opposite side is the side across from the reference angle, in this case BC. And the adjacent side, if you were to cover up the reference angle, your finger would touch the adjacent side and the hypotenuse, and it's the adjacent side, which is the side that makes up that angle. That's not, of course, the hypotenuse. So the three primary trigonometric ratios in terms of angle A, we'd say the sine of A is opposite over hypotenuse, which is 3 over 5. The cosine of angle A is adjacent over hypotenuse, which is 4 over 5. And the tangent of angle A is the opposite over adjacent, which is 3 over 4 in this case. Now we want to use the calculator, for example 2, to find each of these ratios to 4 decimal places. So make sure that your calculator is in degree mode. You can change your degree. This is my archaic calculator that still works. So in my calculator I put in the angle first. So I'm going to be putting in angle 63, and then I hit the sine button, and it just spews out the value. So the sine of 63 is 0.8910. Some other calculators you would hit the sine button first and then put in the angle, and then you have to press the equal button. It depends on what kind of calculator you have. The next one is tan of 42, so I'll put in 42. then hit the tan button, and it gives me 0.9004. And then the cosine of angle 75, I'll put in 75, and the cosine, whoops, sorry, I hit tan by accident, 75, and cosine gives me 0.2588. Okay, so those are ratios in decimal form for the sine ratio of angle 63, the tangent ratio of angle 42, and the cosine ratio of angle 75 degrees. Now we want to determine the size of angle A to the nearest degree. And so if you know that the sine of angle A is 0.998, what you can do in your calculator is you punch in 0.9980, oh sorry, not 0. Excuse me, 0.9980, and then you either hit inverse or second function or shift or whatever that button may be, and you hit that button and then you hit the sign, and that's how we denote the exponent of -1. That does not mean it's a negative exponent. It doesn't mean that this is 1 over 0.9980, i.e. the reciprocal of that. This notation is just the inverse sign in order to find what angle that corresponds to. Okay, so when you put the value in, hit inverse and then sine, and it'll give you the angle. In this case, the angle is, to the nearest degree, 86 degrees. So it's 86.375, and we'll just round to 86 degrees. Remember, the degree symbol is like the units. On your calculator, you might need to do shift, sine. You might have to do the shift or the inverse of the second function, and then the sine, and then type in the ratio, and then the equal button. Okay, of course, depends on your calculator. All along, of course, make sure you keep your calculator in degree mode. Cosine of A is 0.7071, so we want to find out what the angle that corresponds to that is. So I'll put 7.7071 inverse cosine, and that will give me 45 degrees to the nearest degree. And then for the last example, example C, 0.4663 inverse tan, that will give me 24.9996 degrees, which to the nearest degree is 25 degrees. Okay, and moving right along to the last example, sorry, second last example, we want to solve for x to one decimal place. So we know that this is 32 degrees. We want to find this value of x here. We need to know what ratio to use. Okay, so remember, sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So by looking at the reference angle, you want to see what two sides are involved. Okay, we need the value of x, we have the value of 15, so we know we don't need the hypotenuse, so we don't need to use sine or cosine, and we see that the opposite angle, the opposite side to the reference angle is mentioned, and the adjacent side, that value is given to us, so we're going to be using tangent in this case. So we'll say the tangent of 32 degrees is the opposite over the adjacent, and because we want to solve for x, we see that x is being divided by 15, so we'll multiply both sides by 15, so you get 15 times tan of 32 degrees equals x, because if you multiply the right side by 15 and then divide by 15 as is shown here, 15 divided by 15 is just 1, which leaves us with x. So then, when we punch this in, all we have to do is 32 tan, and then multiply that result by 15, and that will give us x to be 9.4 units. I don't know, let's call this centimeters, and then we'll call this centimeters. And the last example here before we get to your classwork, class time fun for today. Find angle A to the nearest degree. Well, angle A is right here. And we want to see which angles are, or which side lengths correspond to this that are given. We know this is the right angle right down here, angle B. The hypotenuse is across from angle B. That's side AC. And that side BC is opposite angle A. So opposite in the hypotenuse. So we'll be using sine of angle A is the opposite over the hypotenuse. We can divide that. So 5 divided by 12 gives us 0.4166, maybe 7. That's the sine of angle A. Then the inverse sine of angle A equals the inverse sine of 0.41667. Therefore, the inverse sine and the sine just cancel out, so we're left with angle A equal to, and if you just leave this on your calculator, it'll give you more accurate result, inverse sine, and will give us 24.6 degrees, rounded to the nearest degree is 25 degrees. Alright, well that is the work for today. Please work on the first few of these questions for homework, and then work on the rest of them in class tomorrow when you come back to school. So thank you for your attention, and we'll see you in class.